Alright, hello. This is going to be a bit of a different video, but I've been wanting to make this for a while. It's about clock theory because I see a lot of people making mistakes like this, and I want to show it's basically that clock is a lot more simple and there are a lot more equivalences than you might think. So first, I want to go through the rough concept of clock, and I'm going to compare it with 3x3. So clock is a commutative puzzle, and 3x3 is not. What is commutative? Well, you can think of it like, say, addition. Addition is commutative because 3 plus 6 is the same as 6 plus 3. Subtraction is not commutative because 3 minus 6 is different from 6 minus 3. So yeah, the clock is commutative in the same sense that, for example, if I had the moves r prime, u prime on 3x3, I could do, for example, r prime, u prime, and they'll give a solve cube, while I could do r prime, u prime, and that would give a scramble cube. So the same moves can result in different states on 3x3. However, for clock, let's say ur plus 1, dr plus 1, dl plus 1, ul plus 1, regardless of in what order you do it, you still get the same state. Yeah, so why is this important? Now, if you use 7 simul, like I believe most clock solvers watching this video will be, you probably use the Zhang pin set, which is dl, lowercase dl, r, uppercase dr, backslash, uppercase ul, l, and then lowercase ur. Now, the thing about this pin set is the same for all. It's the same for all solves. You use the 7 pin sets, and the thing about this pin set, importantly, which is important for this, is that this pin set is mirrored along this axis. What that means is basically this is a move, and if you were to like mirror it, this is also a move in the pin set. This is a move in the pin set, and if you were to mirror it, this is also a move in the pin set. This is a move in the This is a move in the pin set, and if you were to mirror it, this is also a move in the pin set. Now, it's mirrored along kind of this axis, which is important. The thing about clock is, I mean, this is what I'm going to say. This is the main point of the video, and I'm going to prove it, kind of. For any 7 simul method with the Zhang pin set, which is this, there are only 2 solutions, which is anything from this axis, so this, or anything from this axis, so this, or this. Now, why is that the case? So let's see what happens. Remember when I said that clock is commutative? So whatever order you do dl, r, dr, slash, backslash, ul, lur in, it's going to give the same solution if you do the same. It's gonna do the same thing to the puzzle if you do the same moves. So let's say first doing a z2 flip. Now a dl, let's take the first move. dl, z2 flip away, is a ur, which is also in the Zhang pin set. R, a z2 flip away, is a l, which is also in the pin set. And if you do the same thing, dr is also ul, and slash remains a slash. So if you see, every move is still in the Zhang pin set when you do a z2 away. Similar for x2, when you do this and you do x2 away, this is in the Zhang pin set. This, you do x2 away, this is in the Zhang pin set, and so on. And same for x2, z2. Oh, I guess y2. My bad. Yeah. So why that's important is because clock is commutative. That results in, if you do the same moves, you will end up with the same solution. So how the Zhang pin set works is, if you know the number of ways to scramble a clock is 12 to the power of 14, because there's 12 independent moving pieces, and the number of moves, like separate moves in 7 simul Zhang pin set is 14, and there are 12 ways to do each move. So as you can see, the number of ways to solve a cube using Tommy 7 simul and the number of scrambles is exactly the same. And of course, this is not a coincidence, because then every scramble has exactly one Tommy 7 simul solution from a certain angle. Okay, so a practical application is, for example, in a scramble like this. So you can see there are 2 CE skips, and in terms of D moves, you obviously want to start from memoing from here so that your D move is 1 instead of 5. However, you might look at the scramble and go, Okay, but it's a 6 symbol from here. It's a 6 symbol from here that's more important than D move, so I should start from here, right? Well, wrong. Because it will still give a 6 symbol if you start from here, just that the 6 symbol skip, the symbol move skip will be at a different position. In this case, it will be the 5th move that is skipped. So, just to prove it, if you look here, 0, -3 plus 3 will be a 6 symbol, and obviously we'll skip the first move. But if you remember from here, let me just do the memo. 0 to C to A. You will skip a move. 2A, and if you see, you skip that as well. And you also had a lower D move. So that means that that is the best way to solve this scramble. And as a final note, the beatball method also follows the same principle, just in a different order. So that's DL, R, DR, backslash, UL, L, and UR, just in this order instead. Which means that, similarly, because of commutative, there are no scrambles that are better for beatball, because it's the same thing. It's like, it's the same moves, just in a different order. Yeah.